Hi everybody, thanks for tuning in today. Today we're going to be looking at volume. We had a look at surface area the other day, but I want us to go through and have a look at the differences with volume and how they compare with surface area. It's an area where students do get a little bit confused by. So let's have a look at firstly a rectangular prism. Okay, let's say for example it's a rectangular shape there, across to there, across to there, through to there, across to there. Just trying to make the drawings look as neat as possible for you, and that way you can grasp a better understanding through the use of the drawing. Okay, and it goes somewhere in there. Okay. Just make it a bit straighter for you. There. Okay. So we're talking about a 3D object. So we're talking about a three-dimensional shape, and we're talking about two identical bases. So in other words, if you consider that this side and this side here, for example, so we've got two parallel sides that have the same surface area all the way through its length. Okay, guys, that's basically what a rectangular prism stands for. Now, what I want us to do is I actually want us to go through and have a look at the volume. Let's have a look at what we mean when we talk about volume, because this one is quite different. So we saw in when we looked at surface area. Surface area is basically exactly that. It's the surface. It's just the surface area. So imagine if we were to cut. Imagine, for example, this was like a block of cheese, and we were to. Oh, it's a shocking drawing. And we were to cut along the cheese like that all the way down, and we were to cut it and slice it. That would be what we refer to our cross-sectional area, but that's the surface area anyway. Okay, it's essentially a two-dimensional shape, if you want to think of it like that. Now, when we're talking about volume, however, volume is completely different. Volume is actually about, imagine if we were to pour water in this rectangular prism, and we were able to, I'll just take that out, we were able to fill water, completely fill this rectangular prism with water, such that it occupied every space in this rectangular prism. And there's our water. Water is filled to the top, water is filled to the top, water is filled to the top. Okay, that's volume. That's what we mean when we're talking about volume. And let's say it has a length of, we'll say is 8 meters. Say the width. Let's say the width is 3 meters. And let's say it has a height of 5 meters, just to make it simple values. Oh, sorry, 5 meters. Okay. So when we're talking about volume, we're simply talking about volume equals the length times the width times the height, which is simply equal to length is 8 meters. times the width, which is 3 meters, times the height, which is 5 meters. Now again, as we said before, it's in meters, meters, and meters. It's most important that they're the same units. So 8 threes are 24 times 5 is 120. So we've got 120 meters cubed. Okay. So when we say meters cubed, we're actually referring to, that's m to the power of 1, that's m to the power of 1, and that's m to the power of 1. So we've got m to the power of 1 times m to the power of 1 times m to the power of 1. So that's equal to m, and then adding the indices, which is 3. Okay. That's how we determine volume of a rectangular prism. Let's now have a look at another one. Let's have a look at a cone, for example. A volume of a cone. Now, let's say I'll draw a cone. It's there to there, round to there, round to there. Yeah, okay. That's my cone. And it has a radius. And we call the radius, so the radius has a radius r, and it has a height up to there, oh, there we go, of h. And remember, it must be the height at right angles. Okay, it's probably not the best height, but height at right angles. Okay, guys? Very important that it's the height at right angles. And let's say, for example, r is equal to 2 meters and h is equal to 5 meters. Okay. So just make sure that does look a bit better through there. Let's say we do that. Oh, across to there. To there, and it's a right angle. It's just important that you recognize that we're talking about the height at right angles. Okay, so when we're talking about volume of a cone, and again, imagine if we're filling water in this cone. That's what we mean by volume. We're filling this entire space with water. And that's what we mean when we're referring to volume. Okay, volume of this cone. So the volume is equal to 1/3 times pi times r squared times our height. Now, some students find it difficult to understand how to apply the third into this equation. Another way you could look at it is by saying pi r squared h, so it's pi times r squared times h. If you want to say divided by 3, that's probably another way you can do it. If that makes you feel, if you get a bit more comfort understanding it that way, that's okay, because it means the same thing anyway. So pi is 3.1416 or 3.142, whichever you want to use, times that by r squared. Now remember, r is 2 meters, so it's 2m squared times height, which is 5 meters. Okay, remember the units are the same, meters and meters. Okay, so that's now equal to, so when we work out all of that, if I grab my calculator, that all comes to 3.14 1/6 times 4 equals times 5 equals, I'll just check that again, so 3.14, 1/6 times 4 equals times 5 equals, that comes to 62.832 meters cubed. Okay, 62.832 meters cubed. All right. And remember, when we've got 2m, 2m is 2 times 2 is 4, so 2 squared, and then m squared, okay? And obviously times another m makes it m to the power of 3. So that's the volume of a cone. All right, guys? Let's have a look at one more. Now, let's have a look. Let's have a look at a volume of a cylinder. C-Y-L-I-N-D-E-R. Okay, volume of a cylinder. Now let's say I'll draw cylinder through there. Okay, and let's say we come down here, do it a bit longer there. And then roughly in there, okay. Make that part look a bit better through there. That part down through there. Okay, now this cylinder has again a radius. Let's use the same one as 2 meters. So it has R, and it has a height. Okay. It has a height. And remember, we're talking about the height at right angles. All right, guys? So it has a height. Now, when we look at this formula, let's say R is equal to 2 meters, and height we can say is equal to 7 meters. Oh, 7 meters. Okay. Now, what we've got here is that, again, when we're talking about volume, we're talking about all of the fluid, all of the water occupying this space within this cylinder. Imagine this cylinder taking the shape of like a Coca-Cola can. It's exactly that. It's like a Coca-Cola can. And we've poured water into the Coca-Cola can, and all of the water filling up the can is our volume. So it's made up of a surface area. So we can now say that the volume is equal to pi r squared, which in fact is actually the surface area of the circle or of the circle, times our height. Okay, so that's equal to pi 3.1416 times r squared, we know is 2, so it's going to be 2m squared, times our height, which we know is 7 meters. And again, the units are exactly the same, meters and meters. So when we work out all of this, we've got, let's work out what this comes to. is 87.9648 meters cubed. Okay, guys. Hope that's helped you understand volume in a bit more with a bit more clarity, and we'll see you on the next one. Thanks, guys. Bye.